Hey everybody, in today's video we're going to be talking about arcs and chords and circles. So here's some of the vocabulary that we'll be discussing. So to start off, a central angle. A central angle is an angle whose vertex is at the center of a circle. So you'll see the central angle within the circle and the vertex will be the center. An arc is an unbroken part of a circle consisting of 2 points called the endpoints and all the points on the circle between them. So here's a couple of special types of arcs. A minor arc is an arc whose points are on or in the interior of a central angle. So if you look over here, the measure of the minor arc is equal to the measure of the central angle. So here the central angle is angle ABC. The minor arc would be arc AC. Or a major arc is an arc whose points are on or in the exterior of a central angle. So the measure of a major arc is equal to 360 minus the measure of the central angle. So the central angle again is angle ABC. So the measure of the minor or the major arc, which would be arc ADC. Notice how I use 3 letters for major arc and 2 letters for minor arc. So that would be 360 minus this central angle. That would give us the length of this major arc. All right, and then a semicircle. If the endpoints of an arc lie on the diameter, then the arc is a semicircle. And the measure of a semicircle is always equal to 180 degrees. It's just half of a circle, which is 360. So just a little reminder, when you're writing major and minor arcs. So minor arcs should be named with 2 points, and major arcs and semicircles must always be named with 3 points. Okay, so here's an example. We're going to find the measure of the angle of arc MLK. As you can see, it's a major arc because of the 3 letters. So this graph shows the type of grass that was planted in yards in a neighborhood. So we have zoysia grass, we have fescue grass, Bermuda grass, and we want to figure out what the measure of arc KLF is. So arc KLF. So notice how this is a major arc. So to find the measure of a major arc, we're going to do 360 minus the measure of the central angle, KJF. So we're going to find out what the measure of this arc is, which would then tell us 360 minus that answer would give us the measure of the major arc. So the zoysia grass is 20%, so that means that this angle is 20%. Fescue grass is 8%, so if arc GH is 8%, then that means that KJH is also 8%. And then HK, that's 7%, so that means that the angle KJH is also 7%. So now what we need to think about is an entire circle is 360 degrees, but these aren't given in degrees, they're given in percentages. So we need to figure out what percent of the circle do these 3 arcs take up. So first off, we can add them together. 20% plus 8% plus 7%. That's going to give us 35%. So if this is 35% of the entire circle and the circle is 360, we're going to do 35%, which is 0.35 times 360. And that gives us 126 degrees. So angle FJK is 126 degrees of the circle. Now to figure out what the measure of arc KLF is, we're going to just do 360 minus 126. And that gives us 234 degrees. So that would be the measure of our major arc. Our adjacent arcs. So this is kind of like when we did the segment addition or angle addition. It's kind of just like that. So with adjacent arcs are arcs of the same circle that intersect at exactly 1 point. So in this picture, arc RS and arc ST are adjacent arcs. They're next to each other. So the arc addition postulate, since they're next to each other, says if we want the measure of arc ABC, so this whole green arc, then we would do the measure of arc AB plus the measure of arc BC. Notice I'm saying the measure of arc. Whenever you see this little M, this means the measure of. And then you see this arc symbol, that's arc BC, just like with angles. All right, so we're going to find the measure of arc BD. So in this picture, arc BD is the combination of two arcs. It's arc BC, which they didn't actually give us, and arc CD, which they also didn't give us, but we can figure them out. So arc BC should be the same as central angle BFC. They don't give us central angle BFC, but they give us the vertical angle. Angle AFE is 97.4 degrees. So that means that arc BC should also be 97.4 degrees. Now to figure out what angle DFC is, we can look at the semicircle here. So AFC is the diameter. So actually, chord AC is a diameter. It's cutting the circle in half. So that means that arc AEC is a semicircle, so it's 180 degrees. So if we take these two away, it would leave us with just this. So 180 minus 97.4 minus 52, that's going to give us 30.6. So central angle DFC is 30.6 degrees. So that means that arc DC is going to be 30.6. All right, and now lastly, we know BC is 97.4, and we know that CD is 30.6, so we're just going to add them together. And then we get the measure of arc BD is 128 degrees. So that's arc addition. All right, in this next question, we're also going to use arc addition to find the measure of arc LJN. So LJN, notice it's got three letters, L to J to N. That's all of this, but not including arc LM and arc MN. And it just so happens the only two they gave us was arc LM and arc MN. So we want everything except for that, so we're just going to subtract those. So if we add up 40 plus 25 and then subtract it from the whole circle, which is 360, that's going to leave us with 295. So that means that arc LJN is 295 degrees. All right, the next is congruent arcs. So within a circle or within two congruent circles, congruent arcs are two arcs that have the same measure. So in the figure on the right, we see that angle S, I guess we can call this X, SXT, and angle UXV, they both are X degrees. So that means that they're congruent. So if those two angles are congruent to each other, that means that the two arcs that are formed by those central angles are also congruent. So arc ST is congruent to arc UV. So here's a couple of theorems that apply. So if we have two congruent central angles, then the two chords that are formed are congruent. So if angle EAD is congruent to angle CAB, then that means that chord EF is congruent to chord CB. Also the other way around, if we have two congruent chords within a circle, so in this circle, chord ED is congruent to chord BC, then that means that the two arcs are congruent, that are the endpoints. Arc ED is congruent to arc CB. All right, and then lastly, congruent arcs have congruent central angles. So arc ED is congruent to arc CB, therefore angle EAD is congruent to angle CAB. Okay, so we're going to take those theorems and just apply a couple of examples to that. So in this example, it looks like we have within one circle two congruent chords. Chord TV is congruent to chord WS. So since the chords are congruent, that means that the arcs are congruent that are formed by those chords. So arc TV is going to be congruent to arc SW. Now they gave us the measure of those two arcs. We know that they're congruent, so we're going to set them equal. So start off by saying that 9n minus 11 is equal to 7n plus 11. Solve that equation, subtract 7n from both sides, and add 11 to both sides. We get 2n equals 22, and then divide by 2, and you get n is 11. So they want the measure of arc WS, so we're going to plug it in right here. Since n is 11, we're going to do 7 times 11 plus 11, and that comes out to be 88 degrees. So arc WS is 88 degrees. All right, in this next example, brings back this word bisects. So ray PT bisects angle RPS. So RPS is this big central angle. It's bisecting, which makes two congruent angles. So RPT and angle TPS are congruent to each other. And if angle RPT is congruent to angle TPS, then that means that the arcs are congruent. Arc RT is congruent to arc TS, and therefore chord RT is congruent to chord TS. So we can set them equal. So this goes through each step. Set them equal to each other. Add 4x to both sides. We get 10x equals 20. And then divide both sides by 10, and we get x equals 2. So now we're going to take that 2 and substitute it in to find RT. So RT is right here, so we're going to do 6 times 2. And 6 times 2 gives us 12. So the length of chord RT is 12. All right, and then our last theorems that we're going to talk about, and then one more example. In a circle, if the radius or diameter is perpendicular to a chord, then it bisects the chord. So this radius here is perpendicular to chord EF, so that means it's bisecting it. So these two pieces right here, this part and this part, are going to be congruent. CD is bisecting EF, and it's also bisecting this arc. So arc ED is congruent to arc DF. All right, then this one says if in a circle, the perpendicular bisector of a chord is a radius or a diameter. So we see here that JK is perpendicular to GH, and it's also bisecting GH because it has the tick marks. So therefore, that means that AK must be a radius and JK must be a diameter. So we'll look at one example with that. Find the length of NP in this picture. So we got a lot of stuff going on here, but I do see we have this right angle box. So it means that, so they give us RM is, or RS is 8, RM is 9, so we know the diameter is 8 plus 9, which is 17. They want us to find NP. So what we do know is that RN is also a radius. So if radius RM is 17, then radius RN is also going to be 17. So now we want to figure out what NS is, because we have a right triangle here. So RS is 8, RN is 17. So to figure out what RS is, or NS is, we're going to use the Pythagorean theorem. So we're going to do 8 squared plus SN squared equals 17 squared. So square 8, square 17, and then subtract 8 squared from both sides. We get SN squared equals 225, and then if we take the square root, we'll get that the length of SN is 15. So if the length of SN is 15, then we also know, since RM is perpendicular to NP, we know that SP is also going to be congruent. So that's one of our previous theorems. So if NS is 15, that means that SP is also 15. So we're just going to do 15 plus 15, or 2 times 15, and we get the length of NP is 30. All right, so that's it for this lesson. If you do have any questions, make sure you let us know. Have a good day.